Hello guys, my name is Adrian and welcome to my channel. If you are new to the channel, I'm trying here to create a small game framework in order to be used for some game that I'm developing live on stream. In the past videos, we implemented a platform system where we have the window, we handle the window events, input, OpenGL context, and recently we start our OpenGL journey where we started to implement our own OpenGL function loader, and also we implemented the first OpenGL object, the buffers. And today we want to continue our journey and we will talk about vertex arrays. Okay, so like I said, we are not using any third-party library for the OpenGL functions, so we kind of create our own. For today, in order to kind of make the video a little shorter, I prepared some definition for some OpenGL functions. So the function that we will use today, it will be the create vertex arrays. Some of you are very familiar with GL gen vertex array, and it's kind of, let's say, the wide used method these days. But create, the version with the create in the name instead of gen, it's a much more newer version for creating a vertex array. And in general, like in the doesn't matter if we are kind of creating a texture, a buffer, or a shader, we prefer the create version. So we have function to create, delete the vertex array. For the buffers, we didn't have a bind method, but for the vertex array, we need this bind method. Other than that, we have two functions, these ones, that of course we will put more details later. We have these functions which helps us to kind of attach a vertices or a vertex buffer and some element buffer to our vertex array. And we have three functions that are mostly specific to the, let's say, the vertex layout that we want to send to the GPU. Okay, so like in the previous video, I already loaded these pointers to the specific functions in OpenGL, GL create vertex array and so on. And now I will do a new class, which I will call it vertex array. Okay, the first thing, like always, we need to make it available for CMake to be used. And of course, we need to change the namespace to OpenGL. We include here not object, which is the basic object for our, let's say, framework, especially in the OpenGL area. We will include here the buffer, okay, because the header for the buffer has already object. So instead of not having two of them, it's good to have just one. So here final, public, and object. Now, because we kind of inherited from the object, we need to have this create and destroy methods. Of course, this needs to be changed to the OpenGL. Just a second. Let's remove the OpenGL because it's very redundant in this case. And the first function that we will use, very similar with the principle that we use for the buffer. It's called create vertex array. We will specify that we want just one vertex array. And like I told you in the previous video, at some point we will do something like a vertex array manager or vertex array pool, where we will try to use this function just once, or to limit the, let's say, the number of calls that we are doing to it. Here we are using the handle. For now, because we are still in the first videos regarding the OpenGL, all the objects returns for you some unsigned int ID, let's call it this way. So the first element that is kind of created for GPU will start from 1. You have 1, 2, 3, and so on. These are the IDs. Of course, for the functions, the delete array is quite good. The next functions that we will add for vertex array, it will be auto attach vertices, and for it we will take a buffer. Buffer. Just a second, it's called like this, buffer. Let's open this. Okay, buffer. And what we will need when we attach some buffer. So what is this vertex array? It's like I showed you in the previous video that you can create a buffer, but standalone, this doesn't do anything. This is just some memory that we kind of have it for the GPU. But in order to draw something, you need this element called vertex array. What is the vertex array responsible for? It holds the, let's say, we'll call it this way, but it holds sort of a pointer to the buffer that holds the vertices, and of course to the buffer that holds the elements. The second one is not really necessary. You can kind of send some geometry into a buffer and you can specify just the vertices, okay? But in the next videos we will talk more and we will learn more. I don't want to kind of come with a lot of information with a very big package of information. So we have this buffer where we'll have the vertices. In a second we will explain what vertices are. Okay, so we have these buffers, and standalone this doesn't do anything. We need to attach it to a vertex array, and the vertex array will know what to do with that information. So we have something like this. We need to specify a buffer when we want to attach the vertices buffer, the one that I showed you earlier. And another thing that we want to do is something called stride. Okay, just a second. Let's make this a constant void. And this stride is kind of the size for the elements in the buffer. For example, for the vertices, I'm talking about this. I created a short struct vertex, okay, to kind of understand better whatever we put in that buffer. So for us, it's just some position, x, y, z. Okay, and the stride, it will mean the size of this structure. Okay, we have 3 floats and we need to specify the size of these 3 floats, which should be 12, because each float holds 4. So another one, we want to attach not the indices, I will name this elements. Okay, and this one also. And for the vertices, very simple, functions, vertex, just a second, vertex array, vertices buffer, where we will specify the handle. We'll put a 0 for the binding index. We need to specify the handle to the buffer, the stride, like I told you. Sorry, this is the offset. The offset will remain 0. And the last one is the stride. I mean the size of the vertex. Okay, let's make this a constant. And for the second one, it will be like functions. And we call these functions, where we'll have just the handle and the buffer. Another function that we want to do, and just to make use of that, let's just a second change this from buffer to vertex array. Just a second, let's sort this. And what we can already do, somewhere around here, OpenGL, vertex array, we'll call it square VAO from vertex array object. We'll create one and we'll destroy one at the end. And what remains for us is to call this square VAO, attach vertices, and of course we will use the square VBO. And at the end, we will use size of the vertex. Okay. So what we're informing the vertex array is like, hey, I have this buffer where I will keep all my vertices. Okay, all the positions for the geometry that I want to draw on the screen. And I need to specify exactly the size of each element. Okay. So if we are having just the square vertices, we can have a scenario where we have vector and we have also the indices. Okay. And in this case, we will have something like this. Of course, we need to have another buffer for the element buffers. We create and we prepare the storage with core buffer, make data, and we'll use the square indices. Okay, I will name these elements. I like it better. Okay, and that's it. It seems that I have a small problem here. I don't understand exactly why, but we will solve it. Okay, this is a class. I understand. Okay, so just a second. That error will be solved in a second. Good. So now we have some element where we keep the vertices, something for the indices or elements, how you want. And you can have the same for just a second. And this is kind of a very, simple example on how to have two buffers for the indices and for the elements. Sorry, for the vertices and for the elements, or indices, how people likes to call them, and how to create a short class of vertex array and how to attach these buffers. So until now, we make abstraction of what the data is inside here, but we have the buffers and we have the vertex array. Now, what it remains for us? So we know for sure that, hey, I have this data. That's okay. But the problem is that the GPU will not know exactly the format of your data. You are having here the struct. You know that it's an X, Y, Z. You know that those are three floats, but the GPU doesn't know. So you need to specify for this vertex array these attributes. These are called attributes, okay? The attributes for your vertex. So my vertex has three floats, right? And that's pretty much everything. So how do we do that? First, we are going and we are adding a new director called vertex. And in it, we'll have a header attribute. Okay. And now in my vertex array, or not here, just a second, let's do it. Why not here? Include vertex attribute. And now namespace core vertex, we have a struct attribute. And what an attribute for a vertex array has in general. It will have an unsigned int, which will be the index or location, how you want to. It will have an int 32, the size. Okay, the size mean how many members. Okay, I have three floats. My size will be 3. You will have some type. Type means that, hey, I have floats, I have ints, and so on. And the last of them, it will be an offset. Okay, and I will show you now second how to use those. So back to our vertex array. Inside here, we'll have an auto, attach attributes. Okay, because I want them to kind of send them bulk as a list. Sorry, not a list, a vector. So we'll have something like constant std vector core vertex attribute. Sorry, like this. And we'll call it attributes, of course, constant, and it will be a void. Another function also, it will be auto bind. This is very simple. And first, let's implement the binding method. For the binding is very simple. Functions bind vertex array, and we'll use the handle. And we are done with that. What's before we are continuing with the attributes, every time you want to use this vertex array, you want to draw some information from it. What you will need to do, it will be to call square VAO and binding. Okay, and after that you are doing the drawing. Okay, now we need those attributes. So inside here, first, what we'll do, we'll have a for, okay, constant auto, and we will use something, this I think is called binding structure or something not that recently for C++, but it's not that used yet. So we'll have something like index, size, type, and offset, and we will use like this. So these are exactly the same thing as from this, but you kind of write, let's say, less. That's the most important. So we have this for, and we call the first function, and it's called vertex array attribute format. Of course, we have the handle, the index, the size, the type, some 0 for the if it's normalized, the information, and the last of it, it's the offset. After that, we have functions, vertex array, and we have this binding, and what we'll have, it will be like handle, index, and for the binding, we will use 0. Okay, we are not using yet these extra parameters like for the binding. So for now, we'll use it with 0. After that, we have function, vertex, and we use this one with the enable. Okay, and we'll have handle and the index. If you are already a little familiar with OpenGL, you did this with just 2 functions in the past. That was the old way of writing the OpenGL. The difference between this is that you have this new binding point. I imagine this is when you have 2 vertices buffer attached to the vertex array. Yes, it is possible. And probably that's why you need to kind of specify the binding to 0 or 1 or 2, depends on the buffer. And the difference is also that the stride is not part of this situation anymore. It's like you are kind of giving you give that from the beginning. So we have this and an example on how to use those. It will be something like this. We can have a std vector of core vertex attribute. We can call it square attributes. Of course, this list can be reused for multiple geometries that you have. You can use it for the same, like for vertex arrays that holds the same information or very similar. And what we will do here, it will be something like 0, 3, OpenGL constants, float types, and 0 for the offset. If, for example, we'll have another attribute, we'll have like 1, 3, float, OpenGL, not OpenGL constant, float type, and we'll have something like size of 12. Let's say for the offset, like 3 multiplied by 4, 12. Okay, but for now, we have just one attribute. And how do we use it? It's very simple. Square VAO, attach attributes, and so on. I will move this here. Okay. And now, if we are trying to run the project, we should not see anything on the screen, of course, because we are not drawing. But what I can tell you that the vertex array is on. It has the data. If we had implemented some draw command, we could kind of easily see something on the screen. Of course, if we had also the information about the vertices and the elements. But in the next videos, we will do that part. So that's pretty much it. What I will do maybe different, maybe then instead of having this list here, okay, maybe I will have something like attach attribute and call just this function. Maybe it's more cleaner or nicer, depends on you. Probably it is very possible in the future to change it. But maybe for a while I will let it like this. But this is my implementation for the vertex array. In the next video, we'll talk about the drawing commands and commands in general. And that will kind of conclude the part where or how to have something on the screen. We will have a little square on the screen, and we can kind of, after that, we are kind of taking a step forward and we can do more nicer things, especially on the graphic side. So, thanks for watching. Thanks for being here. If you are new to the channel, you can subscribe. I'm trying to put a lot of content. For now, I'm still on the slow pace, but it will be a time when we'll have videos and information daily. And if you like the video, a like is very appreciated. It helps the channel somehow. I don't know exactly, but probably YouTube knows. And yeah, that's everything for now. Thanks for watching. Have a nice day and see you in the next video.